Okay, good morning everyone. My name is Cong. Today I'm going to talk to you about planetary engineering on Mars, the future of human civilization. Alright, a little bit about myself. I'm currently a PhD candidate in the University of Nottingham, Ningbo, China, and I formerly graduated from University of Bath in mechanical engineering. Alright, so before we start, I would like you to give a thought about this few questions. Have you ever thought about live in another planet? Have you ever thought about travel to another planet? What would that look like, and how much time it's going to take? Give it a thought. Well, when you're thinking about these questions, some of you may think, why I am going to another planet? Why human beings are even trying to immigrate to another planet? We are quite cozy on Earth. It's a good planet. It's home here. Well, that is a fair question. So, why? Well, I have to say that human beings have been on this Earth for about 3 million years. And we have possessed what we call human civilization for about 10,000 years. That's what the ancient Egyptian, the Babylonians, what they developed. They're like the original version of us. And it seems like a very long time, but compared to Earth, compared to the universe, 3 million years is still a very short time. In the long term, in 5 billion years later, the sun is going to burn out its fuel and it's going to turn into a red giant star, which means it's going to expand it dramatically, and all this orbit, planet around it, will be eaten by this new sun. That includes Earth and Mars and all those. So in the long term, we're going to die. Human on Earth is going to die. And since the Industrial Revolution in the 19th century, the human activity has changed the environment on Earth. We have increased averagely the temperature about 0.74 degrees centigrade. So, and our scientists find that the most temperature rise we can take is 2 degrees centigrade. So very unfortunately, if we make the temperature rise more than 2 degrees centigrade, a lot of disasters will happen. And we cannot afford to take it. People will die, and the society will be severely damaged. And very unfortunately to that, last year I read a paper about this climate change, and the scientists find out we have just missed the window that can stop the human society avoid the temperature rising 2 degrees centigrade. So we are going to face these disasters in the near future. That is very unfortunately, and so for long term or short term, we need to find a way out. We need a plan B. Well, in our current technology capability, all those Earth-like planets we find is too far away. For example, like the Kepler 452b is 1,400 light years away. We cannot arrive there alive. We're gonna die. So for experience accumulation, for our technology development, we need to look closer. So to find experience, we need to look into our system, the solar system. And that's why we're looking at Mars. Mars is like the most similar brother we have in this solar system. And this is some very basic statistics comparison between Mars and Earth. We can see that the diameter of Mars is like smaller than Earth. It's smaller, which is fine. The atmosphere composite, 96% carbon dioxide. So all those are something we already know. And it's not breathable, of course, but at least it's not poisoning. And the temperature, it's very cold on Mars actually. Much colder than on Earth, but it's still in a reasonable range. And we can do something later about it. And the day length. This is the most point I like about Mars. Every morning on Mars, you have 40 minutes extra to sleep. That's a good point. And the gravity on Mars is like much smaller, just 0.3 Ag. So I'm actually quite light on there, right? So, but don't rush it. There's still homework need to do before we go there, all right? That is what we're talking about today. That is the planetary engineering So what is planetary engineering? Basically, by definition, it means to alter the global environment of planet by applying human technologies, so to make it habitable for human or for other purpose, of course. Well, this is a very large range, this engineering thing. It includes a lot of other like small branches. One of them is like terraforming, which means modifying the atmosphere, temperature, etc., be similar to Earth in order to make it habitable by humans. Or seeding, which means introducing microbial or algae species on the planet that are already offering habitable regions. So to allow these algae and microbials to generate oxygen and change the composite of atmosphere on the planet to make it habitable for humans. Well, in 1973, Carl Sagan published this paper. He discussed about how to make a planet, make this Mars habitable, and he pointed out that the most important factor to make a planet Earth-like is its ability to maintain the stability of climate on it. And along with our technology development, we find that these three factors are the most influential thing that can ensure the planet have the ability to keep its climate stable. The first one is the planetary obliquity. The second one is solar luminosity and albedo of polar. So I'm gonna go through this one by one. The planetary obliquity, it means the angle between the planet axis and its orbit surface. So this is very important because this proper angle may ensure there are atmosphere cycle on the planet, and also it makes sure the climate is not too different. For example, if the angle is too big, all right, so the sun would go really north when it's summer on the North Polar, and it will get really hot, and in winter it will get extremely cold. That is not good for human. And we are very lucky to see that this angle on Mars and Earth are very similar, just like less than 2 degree differences. Because in our current capability, we cannot actually turn a planet, all right? So the second one is the solar luminosity. It means the amount of solar radiation that arrives at a planet. Mars is more distance to sun than the Earth. So it means the sun there is smaller, colder. That is another reason why this planet is so cold. Well, scientists think it's fine because the distance may be long to a human, but in universe is still tiny. And to my personal experience, I spent 4 years in UK. So if UK can survive with no sun, then I think Mars will be fine. All right, just kidding. Okay, the third one is the albedo of polar. It means the solar radiation reflected by the polar cap because ice or other or dry ice. So that is something we can do about. We can do with it, and there is something we actually need to do to Mars to change, because this albedo of polar on Mars is much larger than on Earth. So it means this radiation reflected to the space, and it will cool down the planet. It makes it cold. So our scientists defined 4 steps that if we want to immigrate to Mars. The first one is to create atmosphere. Well, we know although that there are atmosphere on Earth, on Mars, but it's very thin because its gravity is low, and most of them are carbon dioxide. But because it's thin, so it's not good enough. So we need to first create this atmosphere, create a lot of greenhouse gas to warm up the planet and increase the atmosphere pressure on the planet. And then, after this greenhouse gas effect occur, it will then to melt the ice or dry ice on the Mars. It's very interesting that on the polar cap of Mars, very different from Earth, it's dry ice on the polar cap, which means the solid status of carbon dioxide. And the water reserve is near equator in ice. So increasing temperature can release the carbon dioxide to form more greenhouse gas, and also it will help melt the ice, so to form ocean and circulation, rivers. That will allow us to do the next step, which is the seeding. So after we have water, we can then transport algae or microorganism to Mars, and it will grow and it will form proper atmosphere composite for us, mainly oxygen. All right, and then after all this are done, we can then send pioneers. Send pioneers landing on Mars, and they will start build factories, power station, farm. So power station will be mainly in solar power at first, and factory is actually not used to manufacture daily consumptions mainly. It's mainly still about its oxygen generating, and the farms, of course, for food. All right, those are very rough steps, and some scientists have give very detailed plans. For example, some of them say that maybe we can set a nuclear bomb to heat the polar cap, so it can rapidly release the carbon dioxide, create a greenhouse effect, and then the temperature will rise, and then will melt the ice on the equator area. So to form fluid water, form river, ocean, and and also steam water, which is another strong greenhouse gas. So to form this circle, and some others even thinking about capture and aiming asteroid from this space and let it heat on Mars. So this reaction will happen. Like a giant amount of nitrogen and hydrogen will be generated. As we all know that there are like 71% of nitrogen in our air. So making this nitrogen generating is very important step to make it Earth-like. And don't worry about the hydrogen because it's gonna flee. The gravity is low and it's very light, so it's gonna flee to space. Well, I'm actually not saying all these technology plans are feasible or gonna happen. But the most important thing today I want to tell you about is to inspire you to think about the future potential possibilities. Since 1952, Von Braun published his book about Mars project. Human beings never stopped thinking about explored Mars. In 1971, Mars 3 is the first landing probe, and in 2003, the Spirit Mars rover landed on Mars. And all those plans, like Elon Musk even thinking about immigrate to Mars directly in 2018. And Russia also has the same timetable. And the NASA thinking about astronaut landing in 2025. All this, we don't know what's gonna happen in the future. But the thing is, it's very important that we look into it. We start thinking about it. We are now thinking like the original version of engineering, planetary engineering. It's just like what the ancient Egyptians do, what the Babylonians do. They are like the original version of us. They start a civilization. They are important. So, oh, by the way, all those plans I talk about, the fastest one take about 900 years to finish. So you and I here today, maybe all of us, we're not going to see how this is done. But the road is long. The most important thing is start right now. I believe like one day in the future, apart from mechanical engineering department, civil engineering department, there will be another department called planetary engineering department in the university. That is the future. We need this in the future to let us survive. So guys, stay foolish, stay hungry, and most importantly, stay alive. Right? Live long and prosper. Thank you.